prove that root 3 is an irrational number. So we are to prove this in the method of contradiction, proved by contradiction. So before proving this, we have to know the fundamental theorem on arithmetic. The theorem says that if a prime number a divides the product of p into q, means that a divides p or a divides q. So just to keep in mind before proving this. So now to prove this, we have assumed that root 3 is a rational number. So in case of root 3 is rational means that, so we can write root 3 as in the form of p by q, and q is not equal to 0 where p comma q belongs to z. So and p by q is in the form of a standard form, which means that p comma q has no common factor other than 1, has no common factors. Other than 1. So now, since by our assumption, root 3 is p by q means that, so p is equal to root 3 into q. Or on squaring, we have it as p squared is equal to 3 into q squared. Or we can write this, the p into p divides 3 is equal to q squared. Is by the fundamental theorem on arithmetic, if p into p is divided by 3, means that 3 divides p and 3 divides p, which implies as that p is divisible by 3. Since p is divisible by 3, so it may be a multiple of 3. That means it is in the form of 3 into k, where k be any integer. And with using this, we can write as 3 into q squared as p squared. That means 3k and 3k the whole square, which is 3 into 3, which is 9 into k squared. Or otherwise, we can write q squared is equal to 3 into q squared by 9 is equal to k squared, which implies as that q into q divided by 3 is equal to k squared. Once again, using the same theorem, it implies that q is divisible by 3, because q into q is divisible by 3 means that 3 is a prime, so it divides q or q, that means it divides q, which is q is divisible by 3. So since p is divisible by 3 and q is also divisible by 3, yes, it implies as q has, or p comma q has some common factor. So this is a contradiction. According to our assumption, so root 3 is rational means that, so it will be in the form of p by q, where p comma q has no common factor. But now we get the result as p comma q has common factor. This is contradiction. This is contradiction. Since this is the contradiction, our assumption is contradict. So choose our assumption, that means root 3 is rational is a contradiction. So it to be irrational number. So root 3 is the irrational number. So this is the proof. So if you have any doubt, please comment.